Let us evaluate the double integral. Now you see that if we want to do it directly, then we need to evaluate integral of e to the power y cube dy, but we do not know the closed form for e to the power y cube dy, or it may not be possible for us to evaluate the integral. But is there a way out? The answer is yes. What we will do is we will change the order of integration. In other words, we will evaluate with respect to x first and then with respect to y. In order to do so, let us draw the x-axis and y-axis, or let us set the area. Let this be x-axis and let this be y-axis. So we got x-axis and y-axis. Let this be 1, 2, 3, and those be 1, 2, 3 as well, corresponding to y equal to 1, 2, 3 and x equal to 1, 2, 3 and so on. Now we want the curve y equal to 1 and y equal to square root of x by 3. Y equal to 1, that's a straight line parallel to x-axis. So we got the curve y equal to 1, that's a straight line parallel to x-axis. What about y equal to square root of x by 3? That's same as saying y square equal to x by 3 or 3y square equal to x. We know that that's a parabola symmetric about x-axis. So we draw the curve y equal to square root of x by 3. Now as per the question, y is changing from y equal to square root of x by 3 to y equal to 1. So y is changing from y equal to square root of x by 3 to y equal to 1. Once again, y is changing from y equal to square root of x by 3 to y equal to 1. Once again, y is changing from y equal to square root of x by 3 to y equal to 1. So we draw the shaded region. And then x is changing from x equal to 0 to x equal to 3. X is changing from x equal to 0 to x equal to 3. Let's draw the line x equal to 3. Okay. So we want to change the order of integration. So we draw the vertical strip. Can we do same thing? So let's draw the region once again. So instead of drawing vertical strip, let us draw the horizontal strip. So we would like to change x from x equal to 0 to x equal to 3y square. So we can cover the exact region if we change x from x equal to 0 to x equal to 3y square, and then subsequently y from y equal to 0 to y equal to 1. Once again, we change x from x equal to 0 to x equal to 3y square. Let's write it down. We change x from x equal to 0 to x equal to 3y square, and then y from y equal to 0 to y equal to 1. Is the given integral same? Yes, because we got the region to be same and also the area to be same and the function to be same. If the region is same, then the area that we are integrating is same, or if the region is same and the function is same, then the integral should also be same. So given integral must be equal to integral x from 0 to 3y square of y cube dy, and that has to be subsequently integrated with respect to x. No, y cube dx. X is changing from x equal to 0 to 3y square, yes, and then subsequently to be integrated with respect to y. Let's do it. Okay, integral of y cube or e to the power y cube, if we are doing it with respect to x, that's simply equal to e to the power y cube times x. Because if we are integrating with respect to x, then we treat y as constant. And we are changing x from x equal to 0 to 3y square. That's done. In an integral so simple, right? Yes. What about outer integral? Y changing from y equal to 0 to y equal to 1. This expression dy. How much is this? If I write x equal to 0, I get 0, so the lower limit is simply 0. What about upper limit? You got e to the power y cube. When I write x equal to 3y square, then 3y square. Okay, that has to be integrated from 0 to 1. Well, we know the closed form for e to the power y cube 3y square. That's simply equal to e to the power y cube. And we need to change y from 0 to 1. And that is equal to e to the power 1 minus e to the power 0. That's 1. Wow, done.